Good day, I'm Dr. T and welcome to my dining room. Today I'd like to talk about naming simple molecules. Molecules can get incredibly and even profoundly complex, and there's a whole naming system for compounds that contain carbon. That we will deal with in organic chemistry in Survey 2. However, for simpler molecules, there's a fairly straightforward naming system, and I'm going to show you a few molecules and we're going to discover that naming system as we go. Okay, first molecule to show you is going to be S2O4. Okay, now with molecules, with these nonmetals doing covalent bonds, there's no ions involved. So there's also not going to be a charge ratio thing. So if this was sulfur and oxygen and they were forming ions, which would be kind of weird since they're both nonmetals, but if we had a compound where we did have ions, so we could figure out what the ratio of ions were from the charge of the ions. Well, there is no charge. We can't do this. So what I need to do is in the name actually tell you the chemical formula. These are actually easier to do than the ionic ones because I simply tell you the chemical formula. I will point out that these are structured in the same way that the ionic names are structured, just with one very obvious addition. Okay, so first thing I'm going to do is I'm going to describe that coefficient with a prefix, and it's going to be a Greek number prefix. So for a Greek number prefix for 2, that would be di. So this is going to be disulfur. And then Greek for 4 is tetra. Now, you'll notice something right off the bat. Greek for 4 is tetra, but I'm only going to put I can't even pronounce it. Because if I didn't do this, I would run into an interesting problem. See, if I tried to write it out, tetraoxide, that right there would become a pronunciation mess. Tetraoxide. Yeah, no, we don't do this. We drop that A. If the prefix ends in an A or an O, and most of them do, and that's coming up against an A or an O for the element's name, which it's going to be if it's oxygen. And I don't know if there's many other that you see on a regular basis. But if you get an AA or an AO or an OO pairing, or an OA, I guess, then you're going to drop the vowel at the end of the prefix. And that's basically just to keep it pronounceable, like I can pronounce. Anyways, so let's go for a couple more, just see a couple of little differences. We can do into O. It's going to look very much the same way. So in this case, it's going to be di, but it's nitrogen. And then mon, it's not going to be mono. The prefix is for mono, but this is going to be mon, and then oxide. Once again, if this was coming before, say, a nitrogen, it would be mononitrogen or mononitride. But it's not. It's coming before an oxide. Okay, let's go for a couple of more. Actually, what I want to do is show you another quirk to this one, because really we've covered it. This is basically it. There's only one more major quirk that I need to show you. Okay, so let's look at CO2, and you already know the name of this one. When the first element starts out with just one of them, then we don't write the mono. Did I spell carbon right? Yeah, I did. And then we're going to put the prefix. Now, di ends in an I, not an A or an O. Dioxide is pronounceable. Therefore, we use that because there's no pronunciation issues involving that. Keeping the I, that just stays. It's kind of an artifact. It's not an anion. It's just kind of, we already named the anions. That's kind of the way we were going, so we just kind of kept up with it. So yeah, now of course, if you're going to go backwards, then it's actually quite straightforward. So let's go for a name and we'll go backwards. It is as simple as it looks. Let's go diarsenic. Not something you ever want to run into. Diarsenic pentoxide. So from this, I know it's arsenic, so it's going to be AS. I know there's 2 of them because it's a di. I know it's an oxygen because oxide. And I know there's 5 of them because of the pent. There we go. Quite straightforward. Now, when naming these, I should also point out there are a small host of compounds like good old water that, yes, we could name them like this. We don't. And so with that said, have a wonderful day, and I'll see you in later videos.